Okay, sir.
So, okay, in the last lecture, we saw the bisection method, and in today's lecture, we will be going to learn Newton-Raphson method. So first, we will learn what are the assumptions when we are solving given. We want to find the root of equation using the Newton-Raphson method. What is the interpretation of the method, and we will solve one example, and we will look up the convergence analysis for the Newton-Raphson method, and what are the limitations of the Newton-Raphson method as compared to bisection method. So in this method also, in bisection method, we had two initial guesses. Here we will be having only one initial guess, that is x naught. We will be taking initial guess x naught, and the function for which we have to find the root. Okay, so we will be taking initial guess x naught function, and we will find the necessary condition is it should be continuous. The function should be continuous. Then only then we can find the derivative of the function. So we also have to find the derivative of the function. So the function must be continuous. Then we will require initial guess x naught, and the initial guess should be such that f dash or the derivative of function x, f of x, should not be 0 at x naught. Okay, that is the condition, or that is the requirement. Now graphically, how we are approaching towards the solution or towards the root of the equation, we will see. Let us say this blue line, this is function f of x, okay, and we have taken initial guess here, that is xi. Let us say here it is xi. What we will do, we will find the value of function f of x at that point. Also, we will find the slope or the derivative of the function at that point, okay, at x naught, sorry, or xi. At this point, we will find this derivative of this function, and that will be tangent to the function, right, or the curve at that point. Or also we can say that is the slope of the tangent. This is the slope of the tangent. What will be the slope of the tangent? It should be delta y upon delta x, right? So slope of the tangent will be delta y upon delta x. What will be the delta y? At this point, we have f of xi. Here we have function value at 0. So delta y will be f of xi minus 0, and delta x is xi minus xi plus 1. Xi plus 1 is the next value or the next iteration value of x, or the root of the equation in the first iteration. Okay, xi plus 1. What we are doing, we are taking initial guess, then we are finding the f dash of x, okay, and once we find f dash of x, we extrapolate that, or we extrapolate that tangent up to the x-axis, and wherever it touches to the x-axis, that is the next iteration value of the root, or the root of the equation. Okay, and in the next iteration, what we will do, we will again take vertical line from xi plus 1. Then again we will find the f dash here. Then again we will extrapolate until here. Let us say here it will be xi plus 2. Then again we will be doing the same procedure until we reach this root value. What is the root? This point, right? At this point we have function value as 0. Okay, wherever the function value is 0, that is the root of the equation. So that is the procedure. It will be more clear in the next slides. Okay, so now how we will find the xi plus 1? Okay, we have to find xi plus 1. In bisection method we will finding x3, right? And we are finding x3 as equal to x1 plus x2 divided by 2. Here we have to find xi plus 1, or if the initial value is x naught, or the initial guess is x naught, then we have to find x1. Then in the next iteration we have to find x2. That we will be doing. Okay, now as per the Taylor series, the Taylor theorem, we have f of x plus h is equal to f of x plus f dash of x into h. We will have other terms as well, next terms, higher order terms as well, but we have neglected other terms. We will have f of x plus f dash of x into h plus h upon 2 factorial into f dash of f double dash of x and so on. Okay, so but we are taking until the f dash of x only. So we have f of x plus a is equal to f of x plus f dash of x into h. Now we have to find h such that the function value becomes 0, right? When function value becomes 0, that will be our root, right? So putting this value here 0, we will get h is equal to, here h is equal to, here if you put 0 and take f of x on this side, that will be minus f of x, and again we will divide this f dash of x, so we will get h is equal to minus f of x upon f dash of x. Okay, right? So what will be our next iteration value? Xi minus, sorry, xi plus h, right? So this will be our x1 value. So xi plus 1 is equal to xi plus h, but what is plus h? That is this value minus f of x upon f dash of x, that we have put. So we have got xi plus 1 is equal to xi minus f dash f of x upon f dash of x I. Okay, so this is our in each iteration, yeah, equation for the next iteration. Okay, so let us solve one example. In the example it will be clear. Okay, how we are solving. The given function is f of x equal to x cube minus 2x square plus x minus 3, and the initial guess is x naught is equal to 4. Okay, we will find derivative. What will be the derivative? Derivative of f of x, f dash of x is equal to 3 into x square minus 2 into 2, 4x, right? Plus derivative of x is equal to 1, and derivative of minus 3 will be 0. So we will get derivative as 3x square minus 4x plus 1. Okay, we have found derivative. Okay, now in iteration 1, what we have to find? Xi plus 1, right? So or the x1, and what is the formula? Xi minus f of x upon f dash of x. Okay, so we have x naught minus f of x naught upon f dash of x naught. So we will put value of x naught is equal to 4 in this function. We will get f of x naught, right? If we put value of x naught as equal x naught equal to 4 in this function, we will get f of x naught. Let us put, so 4 cube will be 64 minus 2 into 4 square, that is will be 32. 64 minus 32, 32 plus 4, 32 plus 4, 36 minus 3, 33, right? So we are just putting the value of x naught in the f of x and f dash of x. Here and x naught we have 4. So 4 minus 33 and we get f dash of x also equal to 33. So 4 minus 33 upon 33, 33 cancel, 1 here it will be 1, 4 minus 1 will be 3, right? So the next value or the next iteration root we have got as x1. So again in the next iteration we will find x2. Now instead of x naught it will be x1, and f of instead of f of x naught it will be f of x1. Okay, so again we will put the value of x1, that is 3. We will calculate function value at x1. So we will, instead of x1 x here, we will put x1, that is equal to 3. So after calculating for x equal to 3, we get 3 cube minus 3 cube will be 27 minus 2 into 3 square, that will be 18, right? 2 into 9. So 27 minus 18 is equal to 9 plus 3 minus, sorry, plus 3 minus 3. Plus 3 minus 3 will be get cancelled. So that will be equal to 9. And f dash of x will be, or x1 will be 16. So 3 minus 9 upon 16, that is equal to 2.4375. In this way, we will calculate x3, x4, x5 until what we have to calculate? Until the given accuracy is reached. Okay. And we will prepare the table like this. Okay. Here, just do not get confused with the xi, xj. Just remember, like in earlier we were putting x naught, x naught or x1, x2. Just here it is k. We have put, but anything is like we can put I or k or l or anything. That is not a matter. Any letter you can put. But here just realize that here if it is xk, here it will be xk plus 1. Just we are going in the next iteration. So initially we had 4, then we calculated f of x for that value, then f dash f x for that value, and we calculated x1, right? And here we got x1 is equal to 3, right? So we have x1 equal to 3 here, and accuracy will be x1 minus x0, right? So yeah, so but here we are taking absolute, right, in mod, so that will be positive always. Okay, in the next iteration what we will be doing, instead of xk we will be taking xk plus 1, right? So here it is 3, then for that value we will find the f of x, f dash of x, and we will calculate x2 value. X2 we got as 2.4375. Okay, in this way we will calculate, or we will iterate until the accuracy is reached. If the given accuracy is, let us say, 0.01, okay, but here we got 0.03, that is higher, right? Then 0.01. So we will again have to iterate until we reach the accuracy. I hope you have understood this method. I will explain once again if you have little bit doubt. Okay, so first we have been given this function f of x is equal to x cube minus 2x square plus x minus 3, and initial guess as x naught is equal to 4. Now what we will do, we will calculate f dash of x, or the derivative of this function. Derivative of x cube will be 3x square, right? Derivative of 2x square will be 2 into x square, x, what will be the derivative of x square? 2 into x, right? 4x. And derivative of x will be 1. And derivative of 3 will be 0. So we get derivative here. Now we have the formula to find the xi plus 1 as xi minus f of xi upon f dash of x. And we are again doing the same thing, that x1 is equal to x naught minus f of x naught upon f dash of x naught. We are just putting the value of x naught in this function f of x and f dash of x, and we we'll calculate x1, then again we will calculate x2. While calculating x2, here it will not be x0, but it will be x1. And for calculating s3, here it will be x2 instead of x1. Okay. So we will be doing this until the accuracy is reached. Now, let us say here, if you see, we have reached the accuracy in 5 iteration. The iteration should not be start from 0. It should be 1, 2, 3, 4. That is just a mistake. But if you see in bisection method, each time the accuracy was getting like if the initial error was 0.5, in the next iteration the error will be 0.25, in the next iteration it will be 0.125, in the next iteration it will be 0.0625. So each time the error was getting half and half and one half of initial error, right? But here the error, okay, if you see the error in each iteration we are reaching very fast, like error value is getting in the first iteration it was, let us say, higher than like half, but as we go in the next and next iteration the error reduces very fast. Okay, so that's why this method is fast as compared to bisection method. Okay, so this method is fast as compared to bisection method. Now, how we will reach the convergence? Convergence, what we mean by convergence is how we will say that we are reaching towards the root of the equation. Okay, we have given initial guess as x0, and how we will say that we are reaching or we are going towards the solution, that is the convergence. Okay, and when the guess is close enough to simple root of the function, then Newton's method is guaranteed to converge quadratically. When we are close to the solution, then we will be always going for the convergence, or we will have always the convergence whenever we are just near to the initial guess is nearer to our final root. Okay, that is meant by this first point. Now, quadratic convergence means that the number of correct digits is nearly doubled at each iteration. What they are meaning by this is that here we are the error value is getting reduced very fast. The meaning of this sentence is. Now, what are the disadvantages of Newton's method, or what are the problems with this method? Okay, when we will get stuck in this method. Okay, if the initial guess of the root is too far from the, or is far from the root of the method, then it will not converge. The first problem is. And the second problem is, if the f of r or f dash of r is the root, okay, or the final root, okay, r is just the x value where we have this value. This is the r value, or this we are saying is root. Okay, now if f of r is equal to f dash of r is equal to 0, in this case we will have problem for the convergence, and in that case we will use modified algorithms. Okay, again, if we have multiple roots, okay, this function, okay, let us say if f of x is equal to x cube. Now this function has 3 roots, right? Okay, this is cubic equation, right? X cube, or the polynomial with the degree of 3. So it will have 3 roots, right? If the equation is quadratic, then we will have 2 roots. Equation is cubic, then we will have 3 roots. But all the roots are 0 and they are equal. Okay, it has 3 roots: x1 equal to 0, x2 is equal to 0, x3 is equal to 0, and all of them are 0. Okay,
Okay.
Here x plus 1 square, this is the second equation, f of x equal to x plus 1 square. This is quadratic equation and we have two roots and both of them are at x equal to minus 1. Okay, in this case we have problem for convergence, like we will get stuck for the convergence and Newton's method will not be the appropriate method for these cases. Okay, now second case, let us say this problem, we have taken initial guess as x naught here. Okay, and we will go to this point and we will find the derivative or the tangent. Okay, and in the next iteration we will get x1, right? Wherever the tangent touches to x-axis, that will be our next x value. Okay, again we will go to this point, again we will find the tangent or the derivative, and but here if you see here we are going away, right? Our root lies here, right? At this point our root is here at this point, but we are going in opposite direction. Okay, that is called as runaway. Okay, here we have problem with the Newton's method, like here we will get stuck. Okay, now for this function, okay, if our initial guess is x naught and we try to find f dash of x here, how will it will be, let us just imagine the tangent will be like horizontal, like tangent will be at this point it will be like horizontal to the or parallel to the x-axis. Okay, just like parallel to the x-axis, and here also we will get stuck parallel to the x-axis. What do you mean by that is the slope of the tangent will be 0 or f dash of x is 0 at this point. Okay, that is called flat spot. Okay,
Flat spot.
yeah, so here we will have problem with the Newton's method. Now the next case is like, let us say this is the function and this is our initial case x naught. Now here we are finding the f dash of x. Wherever this touches to the x-axis, there it will be in x1. Okay, now from x1 again we are finding the f dash of x1, and wherever it touches to the x-axis it will be our x2. Okay, but here we will be repeating the same steps. Okay, again we try to find the f dash of x2, again we will get here and again we will be just get stuck. Okay, फंस जाएंगे यहाँ, ठीक है? तो इस केस को हम कहते हैं साइकिल. ठीक है, now in this case Newton's method will not be a better method. Okay, so we have sought like whenever we have multiple roots, runaway case, then this flat spot, and then this cycle. Okay, so in all of these cases the Newton's method will have problems. Okay, or it will not be a suitable method. Okay,
Okay, sir.
yeah, so in the next class we will try to derive the convergence condition, and we will see flowchart also for the Newton-Raphson method and the bisection method also, and we will also have one practical, like in each week we will have practical lecture as well, where we will write program to solve the different method. In the first practical, we will try to solve the equation using bisection method. In the next practical, we will solve using the Newton-Raphson method. Okay. So, do you have any doubt in this lecture or anything you want to ask?